Hello everyone, welcome to Engineering Exploration Course Project presentation by Team 13. The course project for our exploration team is seed ball making machine, which is carried out by Ashwin, Rohit, Ashwini and Ranjita under the guidance of Ashwin RK sir. Problem definition. Need statement for our course project is that there is a requirement of a seed ball making machine. Therefore, we should design a seed ball making machine which has semi-automatic working, should be manufactured at low cost, should be portable and user-friendly, and it should notify whenever operation is completed and simultaneously ensure the smooth functioning of the machine. And the constraint is that machine should function at least 3 hours continuously and the weight of the machine should be minimum. Function tree. We have divided the seed ball making machine into 3 important units. First one is input unit, which includes sensing the mud, storage, housing the processing mechanism, sense the seeds, transfer mud and seed to processing unit. And the second unit is processing unit, which includes pushing the mud, pushing the seeds and rolling the clay onto the seed, then moving to output section. Third unit is output unit, collecting the clay balls, notification when process is completed, then dispensing of clay balls. Functional clustering, sensing the mud and seed, then transfer them to processing unit makes input function. Pushing mud and seed, then rolling the clay onto the seed makes processing unit. And at last, collecting clay balls and getting notification, then dispensing the clay balls makes output function. These are the main subsystems identified in our course project: input function, processing function, output function. These are the 4 generated concepts designed by our team. Concept we selected was concept 1 based on several advantages over the other.
Welcome to the virtual implementation part of this presentation. We'll be guiding you through this through our 3D model. So as you can see, this is our total 3D model of our system, and this system is divided into 3 subsystems. This is the hopper part, this is the drum part, and this is the collecting tray. This is subsystem 1, subsystem 2 and subsystem 3. Let us begin with the subsystem 1, that is the hopper part of our 3D model, where we pour in our substances. So our hopper part consists of 3 triangular shaped boxes. These 2 are the big boxes and this is a smaller box, and each of these boxes are connected with a pipe, this pipe, which help in transferring the poured in substances in these 3 boxes to next subsystem, that is subsystem 2. And this is the stand, this is the T-shaped stand which supports our hopper. In these 2 boxes we pour mud, and this one we pour the seeds, and this mud and seed go to the subsystem 2 through these 2 pipes. And this one small triangle box is for our coagulating agent like water mixed with starch, etc. And this pipe drips the water slowly into the subsystem 2 for formation of the seed ball. Subsystem 2 consists of this drum, and this is the stand which holds the drum, and drum is made to roll on these 4 pulleys. 2 are here and 2 are at the other side, you can see this. And a mesh like structure is connected to the stand, of which we will be talking about in third subsystem. And this is our driving belt. This is the driving belt, and this is the driving motor. This is the driving motor, this one, which rolls the drum with the help of the driving bell. The most important or interesting part of this subsystem is that here we use Archimedes screw, which helps in continuous production. See, as you can see these grooves, this is the Archimedes screw. Instead of batch production, we can produce the seed balls continuously. Let's talk about the third subsystem, that is our collecting tray. Our tray consists of a big box over here and a smaller box over here and a IR sensor to detect the height of the heap formed by the seed balls which get collected into this big box. Now this whole tray is oriented in the main system with respect to this subsystem 2 like this. Like this, in the sense the smaller box of the collecting tray gets exactly below the mesh and gets covered with the mesh, and this bigger box is not covered with the mesh. As I said, we have a continuous production of the seed balls instead of the batch production. So when the seed balls get formed over here and when they traverse down the drum over this mesh and they roll over this mesh and fall into this box, bigger box, and the residual mud, residual seeds or the coagulating agent with them, they also traverse with the seed and they come on this mesh also, but they fall off as their size is smaller than the whole of this mesh, individual whole of the mesh. They fall off and they get collected into the smaller box. And the seed balls, as I said, they roll down this box and they fall into this they roll down this mesh and fall into this bigger box. And when they go on forming continuously, we need to stop the machine when this tray gets full, right? So what happens is, as we have a IR sensor over here, you can see this, when the heap of the balls or the heap of the residual, when they come to the height of this IR sensor, the whole machine stops. It's like a kill switch for the machine. So this is our virtual implementation of the seed ball making machine.
Under the virtual implementation phase, we come across the circuit diagram of the entire system, which tells us about the major components involved. The major components involved here is the Arduino Mega 2560 board, an adapter of 9 volt, 2 servo motors, the breadboard to make all sort of connections, an LED, 3 IR sensors and a DC motor. The flowchart or the Simulink model of the entire system, it indicates the procedure the machine follows right from start till the stop. The start initiates with the switch on, leading to IR sensor which detects the clay and seeds. Hence the LED glows, turning servo and DC motor on. The IR sensor at the collecting tray detects whether the tray is filled or not. If the tray is filled, then the machine switches off, hence terminating the process. The bill of materials required for the entire system tells us about the major parts involved, the materials with which parts are made, the specifications of the parts along with the quantity required, telling us whether the fabrication process is required or not. The major parts involved here is the hopper, rod, stand, IR sensor, servo motor, slits, microcontroller, housing of microcontroller, the LED, bolts and nuts, the drum, stand, mesh, belt, DC motor, rollers, tray, stand, legs, and a small tray for housing of microcontroller. Motor sizing and battery sizing of the entire system. We calculate the torque as the product of force and perpendicular distance. We estimate the force to be 25 kg inclusive of the weight of the drum and other mechanisms mounted on the drum. The perpendicular distance is found to be 22.5 cm, including the factor of safety to be 1.5, and hence we calculate the torque to be 84.325 kg per centimeter. This leads us to a conclusion that we require an adapter of 9 volt. The functional specifications of the entire system tells us the functional outputs that we expect a machine to do. The major functional specifications is to store the clay, seeds and water, to sense the clay and seeds, to push the clay and soil and drip the water, to roll the seed balls, collecting the seed balls when the process is terminated, and to notify when the process is complete.
Our course project circuit simulation. This is the IR sensor which is used to sense the presence of mud in the hopper. This is the IR sensor which is used to sense the presence of seeds in the hopper. This is the IR sensor present in the collecting tray to check whether the tray is filled to its maximum capacity or not. This is the LED which indicates that the machine is under process or not. This is the servo motor used for seeds to let them fall in the drum. This is the servo motor used to let mud fall in the drum. This is the DC motor which is used to rotate the drum at a high speed. The simulation. When the mud sensor and the seed sensor senses the presence of mud and seed in the hopper, the machine gets started. That is, the LED starts glowing, the servo motor starts sweeping, and the DC motor starts rotating. The servo motor for seeds sweeps at a higher rate so as to let small amount of seeds fall in the drum, whereas the servo motor for mud sweeps at a slower rate so as to let large amount of mud fall in the drum. As the drum is rotating at a high speed, the seeds get covered by the mud, forming a clay ball. These balls fall into the collecting tray where the IR sensor checks whether the tray is filled to its capacity or not. Suppose the tray gets filled to its maximum capacity, the machine stops working. That is, the LED stops glowing, the servo motor stops sweeping, and the DC motor stops running. This was the presentation of Team 13. Thank you.